Hi math students, this video is going to be for our lesson on linear inequalities in two variables. Hopefully you have already completed the do now and graphed this equation. What we're going to be doing today is really similar. The difference is instead of graphing an equation on a coordinate plane, we're going to graph an inequality. So our goal for this lesson is by the end you can graph solutions to linear inequalities in two variables. I want to start with an inequality that's very similar to this equation. And the question is, what is the solution to the inequality? With equations, we know the solutions are all of the points on the line. But what about an inequality? In order to graph an inequality, you start the same way. So when we graph this inequality, this is still going to be my y-intercept. So I can start by putting a point at -1 on my y-axis. And the number here is still going to be my slope. So I know for this line, my rise and run is going to be 1/1. And I can add a couple more points there. This should be the same as what you did on the do now. The difference is what comes after. For an equation, we draw a line and we're done. But for inequalities, you have two options. For greater than or equal to and less than or equal to, the line will always be a solid line. So that's a line that you're used to. But for greater than or less than, we are going to use a dotted or dashed line. So that's going to look more like this here. So for this inequality, because it has the equal to, I'm going to go ahead and draw a solid line as straight as I can. The other part to graphing linear inequalities is shading. The same way that you shade numbers on a number line for an inequality, we're going to shade part of this graph. The rules we use are for greater than or equal to, you are going to shade up or above your line, and for less than or equal to, you are going to shade down or below your line. Here I have less than or equal to, and so because it is less than, I want to shade down. So I would be shading this part of the graph. So to summarize, I'm shading down because it's got the less than, and I used a solid line because it has that or equals to there. The reason we do that is to help us show where the solutions to the inequalities are. We are shading any pair of numbers that would be a solution to this inequality. So for example, the point 3, 1 is shaded in, and if you substituted that into this inequality, it would say, instead of y, 1 is less than or equal to 3 minus 1. 1 is less than or equal to 2. That's true, and so this is a solution. The reason you choose the line is to show if the points on the line are a solution or not. A solid line is like more shading. It's showing you those are all solutions, similar to a closed circle on a number line. A dotted line is showing those points are not a solution, similar to our open circle. So because this line is solid, it means any point on this line is also a solution. So for example, this point here at 1, 0 is on the line, and if you substituted that into the inequality, it would say instead of y, 0 is less than or equal to 1 minus 1, 0 is less than or equal to 0. That's true. 0 isn't less than 0, but 0 is equal to 0, so it's a true statement. To summarize, the solutions are going to be in the shaded area and then any point on a solid line. And so we could use our graph now to help us identify the solutions. There are two down here for you to try. This first one here is very similar to the one above. Go ahead, pause the video and see if you can identify what is different about this graph. So for this one, your line should be in the same place. We still have a y-intercept at -1, and our slope is still 1, and so I'm rising 1, running 1. The difference is what comes after. Because this does not have the or equal to, you're going to have a dotted line through those points. And because it says greater than, we are going to shade above the line or shade up on the graph. And so it's going back to these two things in this box. Use these examples to help you complete the try it problem, and thank you so much for watching this video.